Section 4.1 is quadratic functions and their models. First of all, we want to look at the general form of a quadratic function, which is f of x is equal to ax squared plus bx plus c, where a cannot be 0. As you can see, if a were 0, then it would not be quadratic anymore. Keep in mind that the graphs of these quadratic functions are parabolas. The parabola is shaped like a U. What we want to be able to do is take this general form of the quadratic function and write it in standard form. Standard form is f of x is equal to a times x minus h squared minus k. Notice that if the a is greater than 0, then the parabola is going to open up. If a is less than 0, then the parabola opens down. The vertex will be the lowest or highest point on the graph. So if the graph opens up, the vertex is at the lowest point. If the graph opens down, then the vertex is at the highest point. Alright, so let's try an example. Let's say we want to express the function in standard form and find the vertex and its intercepts. So let's take a look at this graph, this function f of x equals 2x squared plus 6x. First thing we want to do is make the leading coefficient 1. So remember when we were completing the square in section 1.3, you had to make the leading coefficient 1. We're doing the same thing here. So when we factor out the 2, we're left inside the parenthesis with x squared plus 3x. Then we want to complete the square. So completing the square, you take half of b. In this case, b is 3. So you will take 1/2 of 3, which is 3 over 2, square it, and usually we add it to both sides, but because we're dealing with a function, we will add and subtract. So 3 over 2 squared, I'm adding it and I'm subtracting it. Notice that I wrote the one that I subtracted, I went ahead and squared it and wrote it as 9 over 4. In the next step, what we want to do is remove this last term, the 9 over 4. We want to remove that from the parenthesis because the first 3 terms represent our perfect square. So we want to take that 9/4 out of the parenthesis. In order to do that, we have to distribute the 2 to the 9/4. So when I do that, I get 2 open parenthesis x squared plus 3x plus 3 over 2 squared close parenthesis minus 2 times 9/4. And we can see that our perfect square is going to be x plus 3 over 2 squared. Notice how I leave the 3 over 2 in parentheses. That's so you can see when you write the perfect square that it'll just be x plus 3 over 2 squared. If you FOIL this using the FOIL method, then you will see that you will get the previous step. X squared plus 3x plus 3 over 2 squared. You'll get that. Alright, so when I multiply 2 times 9 over 4, I get 9 over 2. So now my standard form of this quadratic function is 2 times x plus 3 over 2 squared minus 9 over 2. To find the vertex, remember you did transformations back in a previous chapter or section. You did transformations, I believe it was 2 something. But so inside the parenthesis, you're going to take the opposite sign. Outside the parenthesis, you follow the sign. So your vertex is going to be negative 3 over 2, comma, negative 9/2. Alright, then you want to find your x-intercept. To find the x-intercept, we know that we replace f of x with 0. and solve for x. So we do all the steps that we did here to solve for x. Keep in mind, once you get the plus or minus, you want to do negative 3 over 2 plus 3 over 2, negative 3 over 2 minus 3 over 2. So your x-intercepts are going to be 0 and negative 3. And then you also want to find the y-intercept. To find the y-intercept, you replace x with 0 in the function, original function. And so when you replace x with 0, you get 0. So our y-intercept is 0. Our x-intercepts are 0 and negative 3. Alright, so we're ready to graph the function. Keep in mind that a, which in our problem is 2, is greater than 0. And because it's greater than 0, that means the parabola is going to open up, and your vertex is going to be at the bottom. So we plot our points. We plot the negative 3, 0, we plot the 0, 0, and then we also plot our vertex, which is negative 3/2, which is negative 1.5. And then we go left, negative 1.5, and we go down, negative 4.5. And here's our graph. We also want to be able to find the minimum and maximum value of a quadratic function. The minimum and maximum values of a function occurs when x is equal to h. So if a is positive, the minimum value is y equals k. So that means the parabola is going to open up, just like we have in the diagram here. If a is negative, then you know the parabola is going to open down, and so the maximum value will be at the top, so that's why it's a maximum. It's also y equals k. So both the minimum value and the maximum value are equal to k, which is the second coordinate of the vertex. To find the minimum and maximum value of a quadratic equation that's in general form, that is f of x equals ax squared plus bx plus c, you're going to use negative b over 2a, comma, f of negative b over 2a. That is negative b over 2a, comma, f of negative b over 2a. Note that the negative b over 2a is your x-coordinate, and the f of negative b over 2a is your f of x coordinate, which is the same thing as your y. If a is greater than 0, then you know the parabola is going to open up, and therefore the vertex is at the bottom of the graph, and so you have a minimum value. The minimum value is going to be equal to f of negative b over 2a. Likewise, if a is less than 0, then that means your parabola is going to open down, and that means the vertex is at the top of the graph, and so you have a maximum value, and your maximum value is f of negative b over 2a.